In this video, we're going to go over linear motion. That is, motion in one dimension with constant acceleration. This also applies to objects in free fall. Shown here are the kinematic equations that we will use. Note that in each equation, one component is not used. This will come in handy when we actually go to solve problems. The components we're going to use will be position, velocity, acceleration, which will remain constant, and time. In free fall, we're talking about objects that are dropped or thrown straight up in the air. We assume no air resistance. We are now looking at the y-axis, where a positive y means the object is moving up against gravity. A negative y means the object is moving down against gravity. The other thing with free fall is that acceleration is equal to g, the constant of gravity, and because it's always moving in the negative y direction, we use a negative g. Okay, let's do some problems. As with all problems in physics, we should read them carefully first, then diagram the problem and list all of the given information. Here's our first problem. Two cars are at a point such that car 1 has a constant velocity of 30 meters per second and car 2, starting from rest, has an acceleration of 10 meters per second squared. At what position do the cars pass each other? When and where do the cars have the same velocity? What is the position, velocity, and acceleration of each car when car 2 has traveled twice the distance of car 1? So the first thing we need to do is diagram the problem. So here's car 1, here's car 2, and we're given that car 1 has an initial velocity of 30 meters per second, and its acceleration is 0. And car 2 has an initial velocity of 0 because it starts from rest, and an acceleration of 10 meters per second squared. And we're going to assume that the initial position the cars start at, x0 is 0 and the time is 0. For part A, at what position do the cars pass each other? What we're actually looking for is when x1 equals x2. So let's write the equations for x. For car 1, x1 minus x0 of 1 is equal to v0 t plus 1/2 a t squared. Well, we know that this is 0 and that's 0, so we get x1 equals v01 times t. And we know v01 is 30 meters per second, so x1 equals 30t. For car 2, we know that that equation becomes as follows, and we know that v0 is 0 and acceleration is 10, so that becomes x2 is equal to 1/2 10 times t squared, or 5t squared. So if we want x1 equals x2, we have to write then the two equations as such, and if you solve, you get t equals 6 seconds. So 6 seconds is when the cars pass each other. Now that we know the time, we can use either equation to find the position when they pass each other. So we know that x1 is equal to 30 times t, which is equal to 30 times 6, or 180 meters, and x2 is equal to 5t squared, which is equal to 5 times 6 squared, which is also 180 meters. The cars pass each other at 180 meters in 6 seconds. Moving on to B. When and where do the cars have the same velocity? So that would mean we want to know when velocity of car 1 is equal to the velocity of car 2. We know that for car 1, the initial velocity is 30 meters per second, which remains constant. And for car 2, the initial velocity will be equal to AT, which is equal to 10 times t. So V1 equals V2, then 30 is equal to 10t, or t is equal to 3 seconds. So that is when the cars have the same velocity. Now that we know the time, we can solve for the positions of x1 and x2 when their velocities are equal. So we know x1 is equal to v01 times t, and that would be given equal to 30 times 3, which is equal to 90 meters. For x2, the equation would be equal to 1/2 a2t squared, which is equal to 1/2 times 10 times 3 squared, which becomes 45 meters. So the cars have the same velocity at 3 seconds, and car 1 is at 90 meters and car 2 is at 45 meters. For part C, we want to know the position, velocity, and acceleration of each car when car 2 has traveled twice the distance of car 1. So when car 2 has traveled twice the distance of car 1, we actually are looking for when x equals 2 times x1. So first we'll find the time, and we know the equation for the position of car 2 is equal to 1/2 at squared, which in this case is 1/2 times 10 times t squared, or 5t squared, and position of car 1 is equal to Vt, which is equal to 30 times t. So we want to know when x2 is equal to twice times x1, or 60t. If we then solve that equation for t, we get t equals 12 seconds. At t equals 12 seconds, we can find the position of car 1, which is equal to v1 times t, which is equal to 30 times 12, which is equal to 360 meters. We also can find the position of car 2, which is equal to 1/2 at squared, or 1/2 10 times 12 squared, which is 720 meters. The velocity of car 2 is given as at, which is equal to 10 times 12, or 120 meters per second. And we're given the acceleration of car 2 is equal to 10, and we're given the velocity of car 1 is equal to 30, and its acceleration is equal to 0. So we've now found all of the numbers we were looking for in part C. Let's try another problem. A man is standing under a street light. He is 1.8 meters tall, and the light is 6 meters high. If he walks away at a speed of 7 meters per second, what is the speed that the tip of his shadow moves? So let's diagram this problem. So first we have a street light, and we'll call that height h, and we know that's equal to 6 meters. And we have a man standing under it. We'll call his height little h, and we know that that is 1.8 meters. And as this man walks, his shadow moves from right under him out. This creates a triangle that we can label the points on. So let's do that. So here's point A, point B, and point C. We can also draw the man's height straight across to give us a point of H on the triangle. And we can label these points D, E, and F. Now, as the man walks, he's walking from here to here, and we'll call that the position of the man. And we know that his position is equal to his velocity times time. The tip of a shadow moves from beneath the pole to point C, and we'll call that position of the shadow. And we know the position of the shadow would be equal to the shadow's velocity, or v prime, times time. The other thing we can say is that displacement xm is equal to bf on the triangle, which we know now is equal to v times t, and xs is equal to bc on the triangle, which is equal to v prime times t. We can use the properties of similar triangles also to show that E over F is to AB as FC is to BC, and FC is equal to BC minus BF over BC, and that's equal to H over big H. And that is then also equal to V prime t minus Vt over V prime t. So now what we want to do is solve for V prime, the speed that the tip of the shadow is moving. So we want to solve this equation for V prime. So H over big H is equal to V prime t minus Vt over V prime t. And that's equal to 1 minus Vt over V prime t, which is equal to 1 minus V over V prime. So if we add V over V prime to the left side and subtract H over big H to the right, we get this equation. And that's also equal to H minus little h over big H. Now let's invert the equation. We get V prime over V is equal to H over H minus H, or V prime is equal to HV over H minus H. And we know these numbers. Big H is 6 meters. Velocity of the man is 7 meters per second. And again, big H of the lamp is 6 meters minus the height of the man. And this comes to 10 meters per second. The tip of the shadow of the man is moving at 10 meters per second. Let's do some free fall problems. Remember that in free fall, instead of the x-axis, we will be using the y-axis, and acceleration will be equal to minus g and constant. So here's our first problem. A boy leans over the edge of a roof that is 60 meters high and throws a ball straight up with a speed of 20 meters per second. The ball then falls to the ground below. How long is the ball in the air? Let's diagram the problem. So here is our roof, and we know that roof is 60 meters high. Here is the edge of the roof, and the ball is thrown up with a velocity, initial velocity of 20 meters per second. And we will take this as our initial position, y0 equal to 60 meters. Your initial position doesn't always have to be 0. And we will take the final position where the ball lands, y, as 0. So what we know is we have our initial velocity v0 of 20 meters per second. We have acceleration is equal to minus g, and our displacement, which is y minus y0, is equal to a minus 60 meters. And we want to find t, the time the ball is in the air. So the equation that we will use will be y minus y0 is equal to v0t plus 1/2 at squared. Now, from above, we know that y minus y0 is a minus 60 meters. And we know that the initial velocity is 20 meters per second times time. And because a is now minus g, it's a minus 1/2 gt squared. So we get minus 60 is equal to 20t minus 4.91 t squared. So rearranging this equation, we get 4.91 t squared minus 20t minus 60 equals 0. So this looks like a quadratic equation. And let's review quadratic equations briefly. If you have an equation in the form of ax squared plus bx plus c equals 0, you can solve for x with the quadratic equation that says that x will then become minus b plus or minus the square root of b squared minus 4ac divided by 2a. So if we go back and substitute in our values for this quadratic equation, we will get the following. So let's take this equation, and we get t equals 20 plus or minus the square root of 20 squared minus 4 times 4.91 times a minus 60 over 2 times 4.91. So if you go through the math, you'll end up with t equals 20 plus or minus 39.72 over 9.81. And this can give us two answers. We have 20 plus 39.72 over 9.81, or 20 minus 39.72 over 9.81. This answer ends up as t equals 6.09 seconds, and this one becomes t equals a minus 2.01 seconds. Well, we can't have a negative time for this problem, so this answer is out. And our final answer is 6.09 seconds. That is the total time the ball is in the air. Now let's do our last free fall problem. John is looking at a window that is 2 meters in height. A ball is thrown up in front of the window and takes 0.5 seconds for it to pass by the opening. Find the height above the window that the ball rises to. Okay, let's diagram this problem. So here we have our window, and we'll call its height h, which is 2 meters. And the ball is going to rise to a certain point above it, and we'll call that height little h. We will call the velocity at the bottom of the window v0, the velocity at the top of the window v1, and the velocity when the ball is at maximum height v2. And we know because the ball is at maximum height that v2 will be equal to 0. And the time for the ball to move past the window is 0.5 seconds. We can use the following equations. v1 is equal to v0 minus gt, which is equal to v0 minus 9.8 times 0.5 seconds, which is equal to v0 minus 4.9. And we can use v1 squared is equal to v0 squared minus 2gh, which is equal to v0 squared minus 2 times 9.8 times the height of 2 meters, which is equal to v0 squared minus 39.2. So to summarize our two equations, we have v1 is equal to v0 minus 4.9, and v1 squared is equal to v0 squared minus 39.2. And we will call these equation 1 and equation 2. Now we want to solve for v0 and eliminate v1. So let's take equation 1. v1 is equal to v0 minus 4.9, and if we square that, that's equal to v0 minus 4.9 squared, which becomes v0 squared minus 9.8 v0 plus 24.01. If we then substitute the equation for v1 squared into equation 2, we get the following. v0 squared minus 9.8 v0 plus 24.01 is equal to v0 squared minus 39.2. These cancel out, and we get minus 9.8 v0 plus 24.01 is equal to minus 39.2. If we bring the 24.01 to the right side, we get minus 9.8 v0 is equal to minus 63.2, or v0 is equal to 6.45 meters per second. This is the velocity at the bottom of the window. So now we're looking to find h, the height above the window that the ball will move. Now we know what its velocity is, v0, at the bottom of the window. So we know that v2 at the top of the window is equal to 0. We also know that v squared is equal to v0 squared minus 2gh plus h from our kinematic equations, which is also equal to 0. So if we solve for h plus h, we get h plus h is equal to v0 squared over 2g, or h is equal to v0 squared over 2g minus h. And we know these figures. v0 squared is 6.45 squared, which we just found above, over 2 times 9.81 minus h, which we know is 2 meters. And going through that calculation, we get 41.6 over 19.6 minus 2, or 2.12 minus 2, or 0.12 meters. So the height the ball travels above the window is equal to 0.12 meters or 12 centimeters.